back, everybody. In this video, we're going to learn how to do multiplication and division of fractions. So let's get started. So multiplication first. To multiply two fractions, multiply the numerators and multiply the denominators. In other words, basically multiply across. So for in particular, if you have two fractions, a over b times c over d, we're going to multiply a by c, and that's the new numerator, and b by d, and that will be the new denominator. So let's try it. So here, if we have down below 2/7 times 3/5, that will be 2 times 3 in the numerator and 7 times 5 in the denominator, and that is 6/35. Multiply the tops, multiply the bottoms. Okay, for 1/11 times 1/3, we'll have 1 times 1 in the numerator and 11 times 3 in the denominator. That's 1/33. Next up, we have 2/3 times 4/7. We'll multiply the numerators. 2 times 4 is 8. The denominators, 3 times 7, that's 21. Okay, so at its simplest, they're pretty simple. Multiply the numerators, multiply the denominators. It gets more complicated than that when there's a simplification you can do, or if there's negatives, or if you're multiplying mixed numbers, but we'll see that here in a little bit. In the meantime, we want to look at and think about the meaning for multiplication, in particular as it applies to fractions. We've talked about the meaning for multiplication before, as you can think of it as repeated addition or making copies of something. For example, when you write 3 times 4, you could represent that or think of that as representing 4 plus 4 plus 4. In other words, we're adding together 4s 3 times. So the 3 tells you how many times 4 is used as an addend. Of course, if you wish, you can think of this as the other way around, that we're adding up 4 3s and you're going to also get 12. Okay. In terms of a story, if you had boxes of 24 cookies, 2 boxes of 24 cookies would be 48 total cookies, and that calculation would be 2 times 24, or 48. And then 5 boxes of 24 cookies would be 5 times 24, or 120. So the multiplication tells you basically how many times, that is, it's a count of how many times another number is used as an addend. When you're multiplying by a fraction, it's harder to think of it that way. That is, how can you think of doing something half of a time or 2/3 of a time, right? So instead, we'll think of multiplication by a fraction as representing taking a part of some larger amount. So continuing with the cookies, if you had 24 cookies in a box, half of a box, okay, if there's 24 cookies, half of a box would be 12. And so 1/2 times 24 equals 12. 1/4 of a box, 1/4 times 24 is equal to 6. 2/3 of a box, 2/3 times 24 is equal to 16. And that multiplication by a fraction can correspond to taking a part of some amount. Okay. All right, so it's good to keep the concept in mind as we proceed. In the next couple of examples, we'll see how to deal with it if we're going to be doing some simplification. So here we have 3/4 times 8/11, and while we could just multiply across, let me do this temporarily, 3 times 8 is 24, and then down below we'd have 44. You'll notice in here that both 24 and 44 are divisible by 4, and so we could divide out that common factor of 4, simplifying. It turns out that with multiplication, it's typically easiest if you do any simplification first. So here, 3/4 and 8/11, the 8 and the 4 both have a common factor of 4. So we're going to divide both the numerator and denominator by 4. So the intermediate step looks like 3 times 8 over 4 times 11. And then we're going to divide 8 by 4, getting 2, and 4 by 4, getting 1. So this will give us 3 times 2 in the numerator and 1 times 11 in the denominator. And that you can multiply, getting 6/11, which is the same thing you would have gotten if you'd taken the 24 over 44 and then simplified that, right? But typically it's easiest if you do your simplification along the way rather than waiting until the end. Okay, And then here also notice that we were able to divide out a factor of 4 from both the 8 and the 4. We didn't need the 4 to be directly under the 8. As long as we can cancel one factor from the numerator and the same factor from the denominator, it is okay. All right, so let's continue. In the next one, we have 2 sevenths times 3 eighths times negative 14 fifteenths. And so we want to look and see about simplifying first, right? So I don't think any of us want me to say, okay, well, 6 times 14, let's multiply that out. And then down below, we have 7 times 8, that's 56, 15 times 56, what is that? Now we have to turn around and simplify it. That's the I love to work way of doing it. So instead, let's try to simplify along the way. So here I can see that both 2 and 8 have a common factor of 2. Let's divide that out. 2 divided by 2 is 1. 8 divided by 2 is 4. Okay, and as in our previous example, the 2 didn't need to be directly above the 8. As long as we're simplifying one factor in the numerator against one factor in the denominator, it is okay. All right, and so next also, we can see that the 3 and the 15 have a common factor of 3 that we can divide out. 3 divided by 3 is 1. 15 divided by 3 is 5. Okay, with all the crossouts, if it starts to look cluttered to you, feel free to rewrite it at any time. Since I'm here showing you, let me go ahead and rewrite this so that it looks a little easier to see. So far we have 1/7 times 1/4 times negative 14 fifths. Okay, so now we can do a little bit more simplification. The negative 14 and the 7 have a common factor of 7 that can be divided out. 7 divided by 7 is 1. Negative 14 divided by 7 is negative 2. Again, don't worry about the fact that we've kind of skipped over this 1/4 that is in the middle. Remember that multiplication is commutative anyhow, and so we could have switched those two fractions if we chose to. So, okay, so we are okay. So now what's left at this point? We have 1 times negative 2, which is just negative 2 in the numerator. Down below 1 times 4 times 5, which is then 20 in the denominator. So here, once again, you want to double check and make sure that you've gotten out all the common factors. It could be kind of frustrating when you do this much work and you still get the wrong answer because you didn't quite simplify all the way. So what looks like happened was maybe I missed that negative 2 and 4. We could have simplified that further. But in any case, when you get around to writing that final answer, take a few extra seconds to double check and make sure that you got it all. Negative 2 and 20 have a common factor of 2. We'll divide that out. That gives us negative 1/10. Okay, and now I know that that's fully simplified. Okay, all right, so we have a couple of more examples to do. So this next one has letters in it, but it's going to work the same basic way as the last one did. So if it's easier for you and the exponents are small enough, go ahead and write out the factors. So we're going to write this as a cubed. There's 3 factors of a and a single b. Down below, we have b squared, a squared. So there's 2 factors of b and 2 factors of a. So now we'll divide the numerator and denominator by a. We're going to do it again, numerator and denominator divided by a, and then numerator and denominator divided by b. Now what's left? In the top, there is a single a, and the bottom, there's a single b. So it's finally just a over b. Okay. All right, let's try our next one. Here we have 3/4 cubed. Taking care of the exponent first, this means that we have 3/4 times 3/4 times 3/4, and that will be 27 over 64. And here there's no simplification that can happen. Okay, so we're done. All right, here negative 4/5 squared, that's negative 4/5 times negative 4/5. And again, no simplification happens here. We end up with positive 16/25. Okay, so there's a couple of examples of doing multiplication. All right, so moving along, in order to talk about division, we need the idea of a reciprocal next. Okay, so two numbers are reciprocals of each other if their product is 1. That is, if you multiply the two numbers together and get 1. For example, 9/10 times 10 over 9, that is equal to 1. The reciprocal of a fraction, to find the reciprocal of a fraction, interchange its numerator and denominator. So the reciprocal of 1/11 is 11 over 1. Okay, let's try it. 4/9, the reciprocal of 4/9 is going to be 9/4. 13/9, its reciprocal is 9 over 13. And then 9 over 1, its reciprocal is going to be 1/9. Sometimes people have a hard time finding a reciprocal of a whole number. Remember that every number except for 0 has a reciprocal. If I asked you to find the reciprocal of 15, remember that 15 is the same as 15 over 1, and so its reciprocal is going to be 1/15. Okay, and again, two numbers are reciprocals if their product is equal to 1. 4/9 times 9/4 is equal to 36 over 36, or 1. Okay, 0 is the only number that doesn't have a reciprocal. If you're trying to find the reciprocal of a negative number, so -3/16, you can basically just keep the negative number or the negative sign out front and then interchange the numerator and denominator. So if you want the reciprocal of -3/16, that'll be -16 over 3. And once again, you can always check to see if the two numbers are reciprocals by multiplying the two numbers together and ensuring that you get 1. Okay, our reason for looking at reciprocals is because that's how we end up doing division of fractions. To divide two fractions, multiply the first fraction by the reciprocal of the second fraction. So in terms of letters, A, B, C, and D represent numbers, and D is not 0. B, C, and D are not 0. Then A over B divided by C over D. You notice the first fraction, A over B, is going to stay the same. So A over B stays the same, but then we're going to replace C over D by its reciprocal, which is D over C. And then once we've turned it into a multiplication, we just do the multiplication as we were doing just a couple of minutes ago. A times D in the top and B times C in the bottom. Okay? So to do a division, we're going to multiply by a reciprocal. Okay, so for 4/5 divided by 1/8, the first fraction will always stay the same. There's 4/5. We'll change our division into a multiplication. There it goes again. Sorry, 4/5 times 8 over 1. 4/5 stay the same. Divide turns into multiplication. 1/8 turned into its reciprocal, which is 8 over 1. No simplification is possible here. 4 times 8 is 32. Down below, 5 times 1 is 5. So all we've got is 32/5. Okay, 14/17 divided by -2/5. We'll keep that 14/17 as is. We'll change the division to a multiplication. Our second number, -2/5, will still be negative, but we'll have 5 over 2. Now that you've turned it into a multiplication, we can do some simplification. Here the 2 and the 14 are both divisible by 2, so let's go ahead and divide those out. That will give us 7 over 17 times -5 over 1. No more simplification is possible. We'll multiply across, getting -35/17. Okay. All right, so a couple of examples involving division. Okay, more examples. This one has some letters in it. Here it says we're going to divide 3y over 4 by 5y cubed. So we'll keep the 3y over 4 the same. We'll turn the division into a multiplication, and then the 5y cubed will now be in the denominator. We'll have 1 over 5y cubed. That's the reciprocal of the 5y cubed. Okay, so now in terms of the constants, there's no simplification that can occur. We have basically 3y over 20y cubed. There's some y's that can be removed, however. So we have 3y over 20y, y. And so we'll divide out one factor of y from the numerator and denominator. And that will leave us with 3 over 20y squared. Okay, all right. An example where we're evaluating an expression. If x is equal to 7/8 and y is equal to -1/3, we're going to find their product and their quotient. So xy first, that will be 7/8, there's x, times y, -1/3. No simplification is possible here. We'll multiply across, we'll get -7/24. For x divided by y, that will be 7/8 divided by -1/3. We'll keep our 7/8 as is. We'll replace the -1/3 with -3 over 1. And instead of dividing, we are multiplying. No multiplication is possible. Sorry, no simplification is possible. We'll multiply across. We'll get -21 over 8. Okay, so in short, to do a division, we're going to turn it into a multiplication problem. Okay, a couple of story problems. Here it says Hershey Park is an amusement park in Hershey, Pennsylvania. Of its 66 rides, 1/6 of these are roller coasters. We want to know how many roller coasters are in Hershey Park. So when we think about what's going on in here, picture all of the rides. Maybe there's a list of them or something on the map to the amusement park. And 1/6 or a part of them is roller coasters. So if you had this list and you were taking a part of it, that's on the 6th of the 66 roller coasters, taking a part of that whole number of 66 sounds like multiplication by a fraction. So we will have 1/6 times 66. 66 is the same as 66 over 1. Now we can see that we can have a simplify out a factor of 6 from the denominator and the numerator. That will give us 1 times 11 over 1 over 11. Okay, if you looked at that and just said, okay, well, yeah, 66 divided by 6 is 11. Yes, that's the same thing. I did the work here in more of a kind of a fractions way of thinking about it, but you're absolutely right if you said, well, 66 divided by 6 is 11, because dividing by 6 is the same as multiplying by 1/6. Okay, example. In the United States, 7/50 of college freshmen major in business. A community college in Pennsylvania has a freshman enrollment of approximately 800 students. How many of these freshmen might we project are majoring in business? So out of the 800 students, a part of them, that 7/50 is majoring in business. So if we're going to take a piece of that 800 students, we're going to be multiplying by that fraction, that 7/50. So 7/50 times 800 over 1. Definitely a good idea to simplify where you can here. 50 is divisible by 50. 800 is 16 times 50. And so we can divide out the 50 here. 800 divided by 50 is 16. And so up top, we have 7 times 16. And then down below, just a 1. So that's 70 plus 42. That should be 112. Okay. All right. So here we saw that multiplication by a fraction is used to take part. All right. So that takes us to the end of our work with multiplying and dividing fractions. Let me know if you have any questions on that, and have a great day.